Hello, so today we are going to do this problem called Backspace String Compare. So the problem says we get two strings, S and T, and we want to return true if they are equal. The nuance here is that the string can contain a backspace character, and the backspace character means we need to delete the character to its left, right? So basically, after backspacing an empty text, the text will continue empty. So this is a note where basically if we have something like just a backspace, then we can consider it as an empty string. So the first example we have is this one here. And so this backspace deletes this B, and then this backspace deletes this D, so we have AC. The backspace, of course, just deletes the character and is not in the result. So AC is equal to AC. The second example here is we have two backspaces. This is very important to handle. And so this one, you can imagine that one deletes this one and then the other one deletes this one. So we end up with an empty string. And here, this one deletes D and then this one deletes C. And so we end up with two empty strings. They are equal. If we take a look at this one, this backspace deletes A, so it deletes what's left to it. And then we have C and B, they are not equal, so we return false. So that's the idea of the problem. Now, how can we solve it? The first solution I'm going to do is going to just apply the backspace on both strings and then compare them. And we can do it in a recursive way, and then after that we can do it using a stack. So let's jump in. Okay, so how can we solve this problem? So the method that I'm going to do is we take S and T and then apply backspace into each. And we apply 2T as well, which means basically if we encounter a backspace, we delete the letter before it, right? And then we check if they are equal. So that's pretty much what we are going for. So how do we apply backspace? So one solution is to use recursion, right? And do it backwards. So we start, for example, at n-1. Right, and then we check if it's equal to basically if it's not equal to the backspace character, then what should we do? We should just add it to our result at the end, right? So add to res at the end. However, we need some way of keeping track of skips, especially for cases like the one in the example where we had AB and then two backspaces. We need to count how many we have, right? So for that, we can introduce another parameter in our recursion called skip, right? And keep track of it. So I'll just add that somewhere here. So let's say we have skip, starts out as 0, and then we have our result. And so now our result has C. Okay, and so we advance our pointer, and now our pointer would be at this position. It's equal to backspace, so we need to increase skip to 1 and advance our I pointer. Advanced here is going backwards. Now it's not equal to this, but we have a skip, so we can just not add that one because we have a backspace. So we skip and decrement because we used it. And so now our E moves out here. It's not equal to backspace. Our skip equal to 0, so we should add it back. And now we get A. And so we get the result AC. And then if we do the same thing for T, which is equal to AD backspace C, we are here first at n-1. We need our res, and then we need our skip. So skip initially is 0, and then res, this is good, so we add C. We move here, we are at I, it's equal to backspace, we increment this, we move here. Skip is not equal to 1, so is equal to 1, it's not equal to 0, so we can just move off this one and use our skip, so it becomes 0, and now we are at A. Skip equal to 0, A is different than backspace, so we add it and they are equal. Another example that they gave in the problem that is very important to get right, which is AB and then two backspaces. So this is important because we have to take into account these two backspaces. So let's see if our method here would work. So we have I here at the beginning, and then we need two things. We need res and we need skip. Initially they are at 0, as res is empty. Okay, so it's a backspace. Increment our skip, we move, so our I is here. Now we have two skips, right? So we remove this and our pointer is here. B, skip is not equal to 0, so we use that and we advance, so we have only one skip left. And now we have A, it's different than back character, but we have skip 1, so we use it, and now it's 0. And then we are done. We are done when the base case is when I is less than 0, right? Yep. And so now we are done and our res is empty. We didn't add anything to it. So pretty simple idea. What will be the variables for our recursion here? So we can just pass skip, right? And then to count how many we have, we can pass res so that we can know what we have so far. Actually, res is going to be just like the result of the recursion. And then what do we need to pass? We need to pass the index where we are at, and we need to pass the string itself, and that's pretty much it. So let's write this down to make it more clear. Okay, so now let's see how we can write this down. Okay, so we need our function that applies backspace, so let's just call it apply. And as we said, we need to pass the string, we need to pass the position, and we need to pass how many skips we have so far. And then at the end, we just apply it to both s and t. So we start out, as we said, with length s minus 1, and skip initially is 0, so we can just initialize it to 0 here. And then we check if that's equal to apply for t and the length t minus 1. So I starts at the end. Okay, so now we need to apply our function. So we said the base case is when we reach the end. So I is when we reach the front, so we are done processing, and so we just return an empty string. Now we check if the character we are looking at is different than backspace character. Then it depends on whether we have skips or not, right? So if we have skip, then we need to use it, right? So we apply and advance I, but we also use our skip. So we do skip minus 1. You can notice we don't add I here at the end because we have a backspace character, so we need to skip. Otherwise, skip is equal to 0, which means we advance our pointer, of course. Skip is still the same, 0. But we need to add at the end the character, right? Because it's not a backspace character and we don't have backspaces before it. So we need to add it at the end here. And since this is recursion, we need to return this, of course, and return this here as well. Now, what happens if it's equal to the backspace character? What we need to do is just advance our pointer, right? And then increment our skip because we found a backspace so that we can use it. So skip plus 1. And that's pretty much it. So let's run this. Let's run it on our examples. And let's submit. Okay, so this passes test cases. Now let's see how we can do it using a stack in an iterative way. Okay, so let's see the stack solution here. So let's use the same example that we had earlier. So we'll do the same function where we will remove the backspace from S and T and then compare both. But we'll remove letters using the backspace differently. So let's say we have this, which was one of the S examples. So what we'll do is we will do it this time from the front. So we'll start from I here, okay? And we'll have a stack. And so we encounter a letter that is different than backspace. And so when it's different than backspace, we add it. Because we don't know, we may find the backspace and we need to delete it. And we go again, so we move our I pointer here. And now it's different than backspace, so we add it as well. And then we move our I here. Now we find the backspace. So what do we do when we find the backspace? We just pop. So we pop and advance our pointer. So basically when we find backspace, we pop. and then later we push it. So that's what we'll do. And then now at I, it's equal to, sorry, this was B here. I should, yeah. So we remove B, and now we advance, we are at C, we add it. And then at the end, we just join the strings that are in the stack, so this ends up being AC. And a similar thing will happen for T. So T is equal to A, D, C. And our stack will be like this. And so first we start out with I at the beginning. So we add A, we move I, we add D, we encounter a backspace, we pop. And then we move I here, we add C. And at the end we join the content, so it's AC, so they are equal. And if to just make sure this works for the case with multiple backspace characters, let's use the example where we have 2 backspace characters. So again, we have our stack. We add A. Okay, we have our I here. We move it, we add B. We encounter a backspace. So we pop and move I. We encounter another backspace, we pop again. And then we join, but the stack is empty. So when we join, we get just an empty string. And that's exactly what should happen because these two delete everything. So that's the main idea here. Now let's write it and make sure it passes this case. Okay, so let's write the stack solution here. So what we said, we need to again do apply on both and then check if they are equal. Okay, now let's define apply using a stack. So the first thing we need to do is define our stack. So just an empty list initially. And now we need to go through the string in order. So starting from the first character. And then we check if it's equal to backspace, then we need to pop. But if it's different, then we just need to add the character. But if it's different than backspace, we just add it. And then if it's equal to backspace, that means we need to pop. But we need to be careful here. What if we had a case where, like this, where we have this, A. So this here should just be A. It should just be A, right? Because the backspace deletes nothing, so it's empty. So to handle that, we just check here if the stack is only if it's not empty that we pop. So that we don't get an error. And then at the end, we just join what's in the list. And that's pretty much it. So let's run this. Okay, so this needs to be aligned properly. Okay, sorry about the indentation here. Okay, I'll submit. And that passes test cases. One thing you can do, not really very important, but just this for loop here, we can actually just use reduce, which is a function in functool. We can use reduce, which basically applies a function to all the elements of a list, and the string is a list of character, and then just keeps adding using whatever function, keeps applying the function we provided, right? And so to do that, we are going to change this slightly. So we would have reduce, we would apply the function apply, and then we pass the iterable. So reduce gets passed the function, and then the iterable, and then an initializer. So initially we will initialize just with an empty list, right? And we'll do the same thing for here. So reduce the function, and then the iterable, and then the initializer. Now what should we do in the apply? So the function will get passed both the result so far, result of applying the reduction so far, and then the character we are looking at. So we don't need the for loop anymore. Now let's see how we need to change this. But we have the stack now is in res, right? So we can delete this initialization because we've done it here. right? And now we just check here. We need to replace this with the result. We pop, so the same thing, otherwise we append. But at the end here, we can just return res. And that should work. Because we don't need join, even we didn't need join in the initial function, because if A, B, C like this is equal to the same thing, then that means AC is equal to AC, right? So we don't need to convert it to a string. We can leave it as a list of character, and that's what we are doing here. So yeah, pretty simple, except we use reduce instead of going through the loop ourselves here. And if we submit this, it should pass. Yeah, it passes. Yeah, so I think that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.